In this chapter, we're going to study trigonometry. This lesson is about using the information you're given to determine whether it's a sine law or a cosine law problem.
Okay, in this lesson here, this is what we call mixed practice. In other words, I'm going to give you some questions here, and I'm going to ask you to solve for some missing information. But I'm not going to tell you whether it's a sine law problem or a cosine problem. You got to figure that out here. Now, basically, I think the easiest way to go about this is remember that with the cosine law, what you needed in order to solve it, if I wanted to figure out what this piece of information was over here, I needed to have these 3 bits of information. Okay, I needed these 3 to be able to solve for what was over there. Or I needed to have all 3 sides to solve for the angles. Okay, so either I need 2 sides and an angle in between to solve for a side, or I need all 3 sides to use the cosine law. Okay? Now, here's the thing. If you can identify that it's not the cosine law, then it must be a sine law problem. And that's kind of how I want you to think that through. Look to see if you can apply the cosine law. If you can, great, do it. If you can't, then that must be a sine law problem. Anyway, that's not 100% going to be accurate. There's going to be ways we can ask this question where we're going to kind of feed you information that's going to make it a little bit more difficult to determine what to do. But this is the general idea. Okay, overall, this is a good approach to follow here. Anyway, let's take a look at some examples, and then just to help you practice kind of making the decision as to what to do. Okay, so in this question here, it says calculate the length of the indicated sides here. Okay, so for this first one, we are looking to find Q. Now, I have an angle. Sorry, I should look at it like this. I don't have a situation where I have an angle and the two angles on either side. Sorry, the 2 sides on either side of the angle. Wow, I said that wrong. In either way, if I was going to use the cosine law, I would have needed angle Q there and this side over here, and I don't have that. So what I want to do here, or what I've got here, is I do have an angle and I do have the side opposite it. So that's a sine law problem right there. So I know that this is going to be 40 over the sine of 52 degrees. Now I would like to get Q out of that, but I don't know this angle. I don't know angle Q, and I need that. However, it is fairly easy to get angle Q because I have the other 2 angles there. So to get angle Q, I will just go 180 minus 52 minus 79, and I get 49. So I know that this angle up here must be 49 degrees. So then I can write that down as the sine of 49. Now I can handle this problem here. So it's going to be cross multiply here. So Q times the sine of 52 will equal 40 times the sine of 49. So Q is going to equal 40 times the sine of 49 degrees over the sine of the sine of 52 degrees. And again, that becomes just calculator work. Okay, move that over there a little bit. So 40 sine of 49, make sure you close the bracket there, divided by the sine of 52, and we get 38.3 centimeters. Good. So that's the length of side Q. Now let's take a look at this one. Here, I'm looking for side L, but notice this, I do have the angle opposite it, okay, and I've got the two sides that surround that angle. So this is clearly going to be a cosine law problem. So L squared is going to equal 20.3 squared plus 13.2 squared minus 2 times 20.3 times 13.2 times the cosine of the angle in between, 75. All right, so now I just go and I enter that all into my calculator here. Okay, make sure that we can see all of that. Here we go. 20.3 squared plus 13.2 squared minus 2 times 20.3 times 13.2 multiplied by the cosine of 75 degrees, and I get 447.6. Oops. But I know that that's still just L squared, so for me to get the value of L, I got to take the square root of that. So the square root of my answer, and I get 21.2 centimeters. Good. Now, if anybody was wondering here, that little dot that I sometimes put across above an equal sign, that just means approximately. So I'm going to round my answer at the end there. Okay, so in this question, they want us to find the size of the indicated angle. So when I take a look at that, now if they want me to find the angle and they give me all three sides, I know that that's a cosine law problem. But here it isn't. Okay, I didn't give you all three sides, but I did give you an angle and the side opposite. So this is going to be a sine law problem. So I'll put 3.9, okay, over the sine of 56 is going to equal 3.1 divided by the sine of that angle there, theta. Or if you want to use A, you can as well. That's okay. Now I'm going to cross multiply, so this will be 3.9 times the sine of theta will equal 3.1 times the sine of 56 degrees. The sine of theta is going to be therefore 3.1 times the sine of 56 degrees divided by 3.9. And so theta is going to equal the inverse sine of 3.1 times the sine of 56 divided by 3.9. And let's see what we get. Okay? That is going to be the inverse sine of 3.1 times the sine of 56. I want to close brackets around that. I want to make sure that I'm only taking the sine of the angle. And then divide by 3.9, close that all off. And I get 41 degrees. Okay, approximately 41 degrees. Whoops. There we go. Now let's take a look at this next one. And here, and I figured there was going to be one like this. Here, this is the cosine law because I've given you all three sides here. So I know that theta is going to equal the inverse cosine of, and I hope I've got enough room here. If I'm looking for theta here, I'm going to be subtracting this side squared in the numerator, okay? So I'm going to be subtracting 16.3 squared, but I'm going to have 13.9 squared plus 18.1 squared. And then down here, this will be 2 times 13.9 times 18.1. So now I go to my calculator, and it'll be the inverse cosine, and I put another set of brackets there, so 13.9 squared plus 18.1 squared minus 16.3 squared, close bracket for the numerator, divided by, open the brackets again, 2 times 13.9 times 18.1, close, close, and there we go, 59.5 degrees, or 60 degrees. Okay, because we will typically round those angles to the nearest whole. And there you go. Okay, hey everybody. Let's take a look at this example right here. Solve the following triangles. Now what we mean by solve is we mean find everything that you don't already know. So in this particular triangle here, I'm looking for angle Z, angle X, and then side little x here. Well, based on the information I've got this angle y and I've got the side opposite it. So this looks like the start of a sine law problem. And in fact, because I've got little z here, you know what? I can use that to solve for angle z. So I'm going to set that up. Okay, let's go up here. So this is going to be 6.7 over the sine of 80. Okay, is going to equal 5.0 over the sine of z. Now, I'll cross multiply and divide, so this will be 6.7 sine of z is going to equal 5, and I know that I'm running into this because I know I'm going to run out of room here in just a second here. Okay, times the sine of 80, because we know that down here, and I'll just write this down here, this is 5.0, let's say centimeters. This is going to be the sine of z is going to equal 5 times the sine of 80 degrees over 6.7. And so now I can state that, just get rid of that, z is going to equal the inverse sine of 5 sine of 80 over 6.7. Okay, so that will be the inverse sine of 5 sine of 80, so I'm just doing that on my calculator over here, divided by 6.7. Okay, and so I'm going to get an angle of 47. Okay, so 47 degrees. Now I rounded that a little bit, so okay, we got to make sure that that's clear. Now, once I know those two angles, I can figure out this one really easily, right? Because this is going to be 180 degrees minus 80, the angle that I was given, minus the 47 that I just figured out. So 180 minus the 80 that I was given minus 47 is going to give me 53 degrees. Okay? And now that I know that this right here is 53 degrees, well, okay, I can do a couple of things here. I could use the sine law again to figure out this side, or I could use the cosine law. Now, let's use the sine law, because the sine law is a little easier, but let's use the original information that I had here. So I'm going to use 6.7 over the sine of 80 is going to equal little x over the sine of 53 degrees, what I just figured out here. Now, there is going to be a little bit of an error here because I'm going to use 53 degrees just the way it sits. Okay, but there was a little bit of rounding that occurred there. Anyway, this will be x multiplied by the sine of 80 degrees is going to equal 6.7 multiplied by the sine of 53 degrees. So x is going to equal 6.7 sine of 53 degrees divided by the sine of 80 degrees. And so x, when I enter that in, okay, so 6.7 sine of 53 degrees divided by the sine of 80, and I get 5.4 centimeters. Okay, so now I've solved the triangle. I know the angle, I know that other angle, and I know that missing side. Those are the 3 bits of information that I needed. Now over here, because I've been given all 3 sides here, this is clearly an example of the cosine law. And so now we just got to kind of do this in order. Let's find angle A first. Okay, this will be the inverse cosine of, and this will be, if I write this in order here, let's say 9.1 squared plus 10.9 squared minus 9.4 squared, all over, we're going to make sure there's parentheses around that, 2 times, whoops, well, I can do that too, 2 times 9.1 multiplied by 10.9, all in the denominator here, and that's all calculator work. Okay, so that will be the inverse cosine, bracket, 9.1 squared plus 10.9 squared minus 9.4 squared, close the brackets, divided by, open them up again, 2 times 9.1 times 10.9, close. Oh, sorry, you can't see that. 55 degrees. Okay, 55 degrees. I got a weird glare there. Okay, let's look for angle B, and let's do the same thing. That'll be the inverse cosine of, now to do B, okay, we're going to subtract the 9.1 there, so it'll be 9.4 squared plus 10.9 squared minus 9.1 squared, all over 2 times 9.4 times 10.9. Okay. And what does that become? Well, let's try that again. So that'll be the inverse cosine of, another set of brackets there. So 9.4 squared plus 10.9 squared minus 9.1 squared. Did I get that right? Yep. Close brackets. Divided by open, 2 times 9.4 times 10.9. Close for the denominator, close overall. And we get rounded to the nearest whole 53 degrees. So that's B and that's A. Now to get C, I'm just going to be lazy here. I'm going to take 180 and I'm going to minus 55 and then I'm going to subtract 53 from it. Because I know that they should add up to 180. So 180 minus 55 minus 53 is equal to 72 degrees. And now I've solved it. All I was missing were these 3 angles. And now I've got all 3. Okay, so our next problem reads, a contractor needs to do some repair work on the exterior of a building. Standing a distance away from the base, he estimates the damaged part to be at an angle of elevation of 40 degrees. So that's him standing right here, looks up 40 degrees. He moves 20 meters closer and looks up again and estimates it at 60 degrees. So the question is, how high above the ground is that little bit of damage on the building here? Now, we've done a question like this before, because what we've got here is we've got a triangle that's not a right angle triangle, butted up against a triangle that is a right angle triangle, because we're going to assume that that wall meets the ground at 90 degrees. And that's a fair assumption here. So what we want to do is we want to use information from this triangle that's not a right angle triangle, so I can't use just regular old trigonometry on it, sine, cosine, tan. I got to use that to figure out a bit of information about this triangle. Let's tell you what, let's use that to figure out this side right here. Let's call this side here y. Okay, so that's going to be this one right here. Okay, so now I need a little bit more information inside here. I've got the angle opposite y, which is good, but I've got this 20 meters here, and I wish I had the angle opposite it. Well, if this is 60 degrees right here, okay, from here all the way to here should be 180. So if this is 60, that means this angle on this side must be 120 degrees. Okay, because 180 degrees minus 60 degrees is going to be 120 degrees. So that's this angle right here. Now the reason why that's useful to me is because now if I take 180 degrees and I subtract 120 degrees from it, and then I subtract 40 degrees from it, okay, I'm going to get what this angle is over here, and it turns out that this angle up at the top here is just going to be 20 degrees. But that's fantastic, because now I've got an angle, and let's zoom in a little bit with this. I've got an angle, I've got the side opposite, and oddly enough, they're both the same numeric value. I want to figure out what y is, and I've got the angle opposite it, so I can use the sine law here. So I can set that up as 20 divided by the sine of 20. Oops, it's okay, except that's not degrees up there. Sorry, that's 20 meters, or feet, or whatever it is, meters. And that's going to be equal to y over the sine of 40. So now I can cross multiply. So y times the sine of 20 will equal 20 times the sine of 40. And then I'll divide to get, whoops, I wanted to write sine there, but actually when I divide that out, I'm going to get y here. Y is equal to 20 sine of 40 degrees divided by the sine of 20 degrees. And that's just calculator work. So on the side here, 20 times the sine of 40 divided by the sine of 20. And I will get 37.6. So that's the length of this side right here, the hypotenuse of this triangle here. It's not the hypotenuse of the obtuse triangle, really, is what I found right there. Okay, because that one doesn't have a hypotenuse, but this triangle here does. And now that I know the hypotenuse and I know this base angle, I can use it to find the length of x here, because this is the opposite side and I have the hypotenuse here. I can just use basic old trig. So the sine of 60 degrees will equal x over y, which I now know to be 37.6. Cross multiply and I will get that 1 times x is x, and then 37.6 times the sine of 60 degrees. And so if I just multiply the value that I just found a second ago by the sine of 60, I will get 32.6 meters. And so that is how high up the damage is on that building. Okay, so for our problem here, I read that Noah is building a treehouse for his children, and he wants it to be in the shape of a triangular prism. So he plans to make the walls 1.8 meters, 2.2 meters, and 2.4 meters long. At what angles do the walls meet? Okay, so we'll just draw out just a triangle here. So let's say 1.8 meters, 2.2 meters, 2.4 meters. Doesn't really matter here. Let's just label them A, B, C. So that's going to make this little a, that'll make this little b, and that'll make this little c. Okay, so let's find angle A to start off with. Because I know all three sides here, I know that I'm going to use the cosine law. So this will be the inverse cosine of, and I'm going to make that, because I know I'm going to subtract this one at the end here, so it'll be 1.8 squared plus 2.4 squared minus 2.2 squared over 2 times 1.8 times 2.4. Okay, actually, you know what? I don't like the way that I wrote that at the end. I'm going to try that again. Okay, 1.8 multiplied by 2.4. Okay, and now that is just calculator work. So inverse cosine, that'll be 1.8 squared plus 2.4 squared minus 2.2 squared divided by 2 times 1.8 times 2.4. And I get that this is an angle of approximately 61 degrees. Okay. Now, let's do that again for B. B will be the inverse cosine of, well, this time I want to subtract the 2.4 from that. So it'll be, let's say, 1.8 squared plus 2.2 squared minus 2.4 squared over 2 times 1.8 times 2.2. Close that, close that, close that all. And again, this is just calculator work. So 1.8 squared plus 2.2 squared minus 2.4 squared. Please remember to be careful with the parentheses. Okay? So we've gone through lots of examples of that thus far. And here I get 73 degrees at the end here. Okay? So here's what I entered in the calculator for that if you need it. Okay, notice the parentheses. Okay. Notice the parentheses at the end there too. Okay. Now, to get angle C, that final angle, all I'm going to do is subtract those two answers that I just got, okay, from 180 degrees. So 180 minus 61 minus 73, and we get that the angle at point C here is going to be 46 degrees.